All right. Good afternoon, everybody. Thank you so much for joining. First off, I'd like to introduce myself. My name is Stevielyn Burd. I'm a key account manager at Roxtec, Inc. Here presenting with me today, we have Karl Rabe of WoodenDataCenter, and we have Zachary Lovett at Holcim. We have quite a bit of information today. I know it's the end of the day, so we're going to try and dive right into it. But the topic for today is analyzing building elements as they relate to data center construction emissions. So today we're going to focus on three main materials, those materials being concrete, steel, and wood or mass timber. We'll discuss material construction and sustainability considerations, and then we'll dive into some current design build best practices that reduce embodied carbon emissions and waste. To close, we'll take a look at innovations or future trends for consideration. And our ultimate goal is to have a white paper publication with our current target timeline for spring of 2024. So when talking construction emissions, there are a few things we'll be focusing on. The first and likely most important is embodied carbon. So between extraction, processing, manufacturing, and transportation, embodied carbon is a significant source of greenhouse gas emissions, accounting for roughly 40% of the total life cycle emissions of a data center. When we are talking water use relating to concrete and steel in particular, the production of these materials requires a significant amount of water. And waste generation, so this includes construction debris, hazardous materials, electronic waste that will ultimately contribute to pollution. And whether that is air pollution or water pollution, it's ultimately going to hold a negative impact on not only human health, but also the environment. I'll pass it on to Zach for his analysis on concrete.
Thank you. So, Holcim, we're one of the largest producers of cement on the planet. We also are the largest producer in the US. And, you know, the production of our product, accounts for about 7 to 8% of global CO2 emissions every year. And as you all know, data centers use a whole heck of a lot of concrete, not just in the building, but you guys use a lot of duct bank concrete and concrete that goes under the ground. You know, some of the challenges from specifically the US standpoint is that the production of cement in the US, a lot of our plants are very, very old because we industrialized much quicker than, you know, the rest of the world. So a lot of our plants, not just of Holcim's, but a lot of our competitors are still relying on older technology that's being upgraded currently, but it's something that you have to really consider, especially in the US, that you just don't have access to some of the other types of cement that you will outside of the US. But you can see here in the graph, this is a typical you know, carbon emissions footprint for a company like my own. So roughly 47% of the emissions that we generate are from the decarbonization process during the production of cement. So even if we were able to, there's two sources of emissions for a cement producer. It's the decarbonization process and then the amount of energy that we use, that we consume to make cement. But even if we were able to switch entirely to green energy, that's only about half of the problem. So there are huge benefits to using concrete. Obviously, it's durable, it's long lasting, it's got a high thermal mass, so it can help with cooling operations and things, but it does have a high embodied carbon, and transportation times are or transportation and logistics are very expensive from a carbon standpoint because you're moving massive amounts of raw materials. One of the things that we've seen a lot of in the industry in the past few years is the adoption of EPDs, which are environmental product declarations for you, those of you who aren't familiar. That can give you an idea of what options are available out there in the concrete world and give you a very clear third-party vetted view of what you're getting when you use the various types of concrete that we produce. I think we can go to the next slide.
So jumping back over to steel emissions. So according to a recent report put out by the IEA, or the International Energy Agency, the steel sector is currently responsible for roughly 7 to 11% of all global CO2 emissions. So some challenges that we face with steel come from the production, right? So resulting in greenhouse gases from high energy uses, generated from fossil fuels, and then in addition, transportation and corrosion susceptibility. But steel, in today's modern world, is crucial, right? It's vital to meet social and economic needs. So some of the benefits of that, of course, is the strength and durability, the fact that it allows for reuse at the end of its lifespan, and the scalability for constant evolution. Now I will turn it over to Karl.
Yes, hi. Obviously, with the short time frame that we have ahead of us to become, aligned with the Paris Agreement, we were looking for alternatives, and me as a startup trying to do that. That's why I'm here, happy to present, a relatively new material in my perspective. Because with the advent of CLT, a lot of new, construction opportunities arise over the past 25 years. And one of the real benefits of this process is that it's relatively quick to process and can be pre-manufactured and shipped to construction site. And it's also obviously in the scenarios that we believe carbon, to handle carbon, we actually think of it as a carbon storage for its life cycle. As long as it's not burned again or decomposing, the carbon is fixed into the CLT. But it still is not without its doubts. In housing deployments, you have issues with noise dampening. There's a lot of other ways to think about it. The first, most natural one is obviously potential fire hazards, which kind of are controlled. But to really have a long-lasting wooden building, you have to have moisture and control. So what are the types of mass timber products that exist? Most commonly are the ones to the bottom, but actually nail lambered timber has been relatively old products, and there are some really old larger panels and walls made out of a number of timber boards connected by nails. Double laminated timber is a relatively new type of material, and with those dovels being made also of wood, it's the most eco-friendly alternative. I all advise you to look up Toma 100. They have crazy health benefits and insulation properties that they highlight. The one that are interesting for us as engineers is glue laminated timber, basically boards stacked on top of each other, and cross-laminated timber, cross-glued boards, which have those real nice construction advantages. With highlighting how enabling this is, we just see real, interesting interesting and challenging wooden structures arise. On the right, you see the tallest wooden building in a CLT building frame is a 34-story skyscraper in Norway. On the left, you have an interesting university building that's also, combination of timber and glass, obviously is quite attractive. But those things just have been recently deployed. We called WoodenDataCenter for a reason, and these are the latest designs that we've implemented together with a customer in Norway, where we try to go even further and combine wooden housing with liquid cooling. And obviously, liquid cooling is a lot of steel and a lot of components, but by reducing some of the steel and concrete, we actually can reduce the embedded carbon per square meter significantly. In terms of how to think about that, what is currently to be done, there you see a lot of pre-manufacturing in this space. So modular housing, prefab housing, the product approach to something like a house is enabled by something that you can relatively and automatedly machine, like CLT and GLT. Oh, still me. So to sum that up, so the real, beneficiary here is that it is in the scenario we believe to be a global warming potential, that carbon is the store and is really differentiating that from steel and carbon. There's obviously a limitation on how much wood we can take out of a natural cycle, but those boards after the life cycle of a building can be reused and repurposed to be used until it's eventually burned. And so that is something that is making this such an interesting material for the time, for the development time that, for example, what Holcim is doing to reduce their embedded carbon.
So current design best practices for concrete. As the cement industry starts to decarbonize, and we're seeing more and more of it, our company, as an example, switched to a type of cement that's been used widely around the world. It's called type 1L versus type 1.2, which 99% of the data centers that anybody in this room has built has used type 1.2 historically in the US. We're seeing, in 2016, a trade organization for concrete benchmarked where we stood as an industry and with regards to CO2 emissions. And every year we've seen that number start to come down with products like type 1L and changing the way we're manufacturing cement. And as you can see from efficiency gains in production on this slide, there's a lot of things we're doing because we use a lot of water, we use a lot of energy. Naturally, we emit CO2 because we decarbonize stone and turn it into cement. So there's a lot of different aspects that we have to work on as an industry. For best practices, what's important to companies like mine is that companies like yours start to accept the new products and the new ways of production that we are coming up with. And a lot of times, like type 1L, it's not new. The rest of the world has been using this for decades. But for the US, it's new. And what we find over and over again is that when specs are written, it's almost too late to go back, right? So typically in the US, we've used ASTM C150 to spec out our concrete and the type of cement that's allowed in that concrete. What we're asking the industry to do is start to open that up and allow C595, which has not historically been a popular portion of ASTM in the US, or really any part of North America, but allow these other types of materials, because what it does is it opens up the book of what we're able to use to make concrete and make cement. We can start to use byproducts from other waste streams, including steel, including ground glass and things of these natures. There's a lot of startups in this area that are working to develop new ways to produce cementitious materials. But again, those will come online and start to scale up to viable levels. But if we don't have a place to use them widely, then they'll never get off the ground. So that's kind of that alternative binders that are mentioned up here. We use a lot of those. We've used them a lot historically, but we need to kind of increase, we really need to increase our allowance and our ability to use those on various projects. And then just mixed design optimization. You know, I can't tell you how many times I look at specifications on data center, not just data centers, any type of project, and see really outdated information. And you know, maybe a problem that somebody ran into in one part of the country in a very specific instance affect the way that they're speccing concrete on the next project. And you know, it's really, really critical that we start to really analyze the way we're speccing out this particular product, because from a cement and concrete manufacturer's point of view like myself, producing this material every day, putting it in the truck and getting it to your job site, and then seeing the results of that from thousands of job sites, being told what to put in my product is somewhat frustrating, if you can imagine, right? Being told, well, this is what I need this water cement ratio, I need these various types of cement, whatever that is. Oftentimes that's quite outdated, and we can really optimize. And that's where, to me, sustainability really, the very low hanging fruit is just mixed design optimization, allowing the people that are producing the material and know the results of the materials they're using to tell you what the best way to, you know, to make that type of concrete is. So, so again, open up your specifications to allow alternatives to type 1-2. We've got to get the U.S. unaddicted from type 1-2 cement. It's the dirtiest type, one of the dirtiest types we can make, and it's been historically the majority of what we produce, especially in the U.S. Not so much outside of the U.S. any longer, but certainly here it's a very common product that we need to get away from. The other thing we've seen successful, especially in your guys' segment, is, you know, setting global warming potential reduction targets or a carbon budget. I prefer a carbon budget. There's all kinds of information you can find. If you have questions about how to do that in your specs, you know, look me up or look up a similar company to my own. But it's becoming more and more popular to say, here's the benchmark that you guys set in 2016 or the study you did. I want to see a 40% reduction or a 50% or a 60% reduction, and companies can do that. We can do that. So the best way to do that is early engagement, because again, once those specs are set, it's like moving a mountain to get them changed. So you really need to have it going into the project, set that expectation for the contractors and the general contractors that are going to work for you. And then really, I think for all of these products, make full use of the LCA tools that are out there, the life cycle analysis tools, that really will show you what the impact from a carbon standpoint and a sustainability standpoint your building will have from beginning to end of life.
Absolutely. So yeah, so when we're talking current design build best practices as they relate to steel, there are a few practices that we already know of that have proven beneficial to the reduction of embodied carbon emissions and overall pollution. Whether it's using high-strength steel versus mild steel to lower the carbon footprint, or using recycled steel that requires less energy in production to reduce emissions. Additionally, we could utilize off-site and modular construction as a more efficient method. I know this is actually something that has been mentioned in previous keynotes at this summit. And then ultimately, we want to design for deconstruction, right? We want to design these data centers for the future. We want to be planning ahead, so that way we can design for decommissioned data centers to be recycled and reused. So some future trends for considerations. We really believe that engagement is the first step, which is why we're here talking with you all today, as it kind of relates to the trend of OCP Summit this year, right? Scaling innovation through collaboration. Having open discussions with data center builders who are already taking steps towards decarbonizing will allow for greater transfer of knowledge between the owner and the manufacturers. So this will ultimately lead to a better understanding of new materials and technologies as they become available. New materials, like Karl mentioned, bamboo, low-grade wood, that are already being integrated into CLTs and GLT production. And then regarding EPDs and LCAs, again, we are continuing to see a rise in request for environmental product declarations and life cycle assessments on products and material. So setting reduction targets in the data center specifications will encourage manufacturers to move faster and move further within their innovation themselves. And so really, to close our call to action, we do have a QR code here if everyone would like to scan it. Ways to get involved: you can join our monthly calls for sustainability. We are in our, I would say, our infancy stage here for the white paper, so we're actively looking for additional collaborators and contributors. So if you have any input, whether it's for concrete, steel, wood, we welcome you with open arms to come and join, collaborate with us, and contribute to the white paper as best you can. And with that, I would like to thank everyone again for sitting in on our session, and I will open it up to any questions that you may have. And thank you very much again to OCP.
For Zachary and Stevielyn, you've shown 7 to 11% for cement and about the same for steel, I think, is the global percentage of contribution of emission. So if I add them up, maybe it's 15 to 20%. What's the data center piece of that? Is it 1%? Is it what's? I'm just trying to get a sense of scale.
That's a hard thing to know because data centers haven't, it's a fairly new segment and something that not a lot of us have tracked. But I would say it's considerable, especially because, and just to be open and honest, y'all don't use the best types of you really use some of the, if we're showing you best practices, you're kind of going through some of the worst practices. I mean, that's rapidly changing, right? But from the beginning, it was just kind of the cheapest, lowest, not cheapest, but the most known and used materials is what everybody seemed to want. That's changing. But as far as what percentage overall globally, it would be fairly low because concrete is so widely used, right? I mean, we do things with cement and concrete that it's everywhere. Everywhere you walk, it's in foundations. I mean, it's so widely used. But I would say this, it's growing rapidly because data center construction is increasing. And you do use, because of your duct bank concrete specifically on a lot of projects, you do use a lot more than like a similar warehouse of that size, if that makes sense.
Yeah, I think as part of this OCP, that might be a nice number if it could be estimated to document at some point.
I think you're absolutely correct. And just to add to Zach's point, it is a number that I viciously did try to find for this presentation.
Same here.
Yeah, again, it's not public knowledge at this moment. You can't really define a definitive answer. But again, we are hoping that perhaps with additional contributors, additional research, by the time we're able to actually go into the publication of the white paper, we will have that information to provide.
I mean, one way to get at it might be to see how much it's per megawatt, and then there might be data out there, how many megawatts of DC space. I know it's approximate, but power is I think there's more documentation of the data center footprint and power. And if you relate your cement and steel back to power, there might be a way to get that.
Yeah, I would think on the cement side, none of us or on the steel side, none of us work for a steel manufacturer. And on the cement side, oftentimes we sell our product to concrete producers, and then we have no idea what exactly their projects are. So unless I'm supplying it out of one of my own concrete plants where I buy my own cement internally, I have no real way of knowing where my customers' materials are going unless they come back to us, which they have in recent years with help on developing low carbon concrete mixes for a data center or something like that where it's been requested. That's when we'll...
I see there's 3 more questions, so
Yeah.
thank you.
Just thing to add to you, Amadou, I had the same initial response, but the challenge is really in the data. If we say 7 to 11 for both of those materials, we really have a data issue that basically those range so vastly, and for the OCP to start the use the sustainability tenant, and for the sustainability project in data center facilities, we really try to help bring accurate data to this. And with the initiatives, especially in the concrete phase by the hyperscalers to solve that, we would solve it for a whole industry, right? We would solve it for every other construction industry. And so that's why this is so exciting and really just a starting point, yeah.
So actually, Madhu hit my question as well, but I wanted to offer some additional perspective as to why that would be useful data. So I've met with the leadership at PCI, I've met with leadership at the American Iron and Steel Institute, Steel Manufacturers Association, and they don't disaggregate the data center as a subsector of the construction industry from just construction generally. And construction isn't necessarily known for being rapid to adopt change. We're sort of this dinosaur of an industry, but the velocity of change in the data center subsector of the construction industry is a much higher velocity of change implementation. And so if those trade associations were educating their membership about like the economic contribution, the material flow that this subsector, data centers relative to construction generally, it might help the membership of those steel and concrete trade association bodies help motivate their membership to invest capital more rapidly because they understood this sector of the economy. So the more data we have about it, the more we might be able to help those makers and doers implement change. And then I did want to make a comment to you, Karl. I'll try to find this article here for you later, but there was an interesting article written about what's happening with wildfires and how it's starting to affect the effectiveness of carbon sequestration of forests, because now we have these massive, our forestry practices are now creating a situation where we have less effective carbon sequestration in forests. And so another argument for more use of mass timber, because we then can retain the carbon sequestration longer and more effectively because we're not leaving them susceptible to these massive wildfires that are happening more and more often. But I'll find that and I'll share that with you.
Thank you.
So Zach, this question's for you. You mentioned concrete manufacturers' technologies are old and outdated, and they are upgrading. But how does the technology or the infrastructure that they have established affect the greenness of the concrete?
A lot of the plants that we have here in the U.S., not just my companies, but every cement manufacturer, they're much older. So for example, our kilns, which heat stone up to 3,000 or 4,000 or 5,000, several thousand degrees, most of the U.S. ones in the U.S. are horizontal. And I don't know, 30 or 40 years ago, 20, 30 years ago, we developed vertical kilns, which for obvious reasons, the heat's going up. You're not losing as much waste heat. It's much more of an efficient process. So even if you're making the same type of cement in a horizontal kiln versus a vertical, you're getting, right? Yeah. But also, there's other types of materials. Primarily we use limestone, we superheat it, and then we add some other things like gypsum and steel and stuff like that. As we're starting to look at alternative materials like calcined clays and other natural materials, because one of the keys here is it has to be scalable, right? We can't pick a material that is hard to get, which you see happen sometimes in research and startups. But as we look at that, you've got to design different kilns and things of that nature. So it's even just switching to 1L, which is what we do with 1L. We take roughly 90% type 1-2, and then we blend in just ground up limestone dust. Because what happens is most of the cement doesn't actually, when it's mixed with water, doesn't hydrate on your data centers. There's a certain amount in your slabs, in your walls, in your columns that never actually hydrates. It just sits there suspended in the concrete. So by taking out about 10% of it, you're really not losing any performance, but also we're skipping that decarbonization process where we superheat it. So even that, though, took a considerable amount of capital expenditure per plant to build these inner grinders that in other parts of the world had been done either because their plants are newer or because the federal government or their governments mandated that you start reducing more so than we have here in the US. So, for example, in Europe, that process of looking at alternative materials, of using waste materials to introduce back into our production process, that began many years ago. Now, the benefit to the US and for us is we can now import all of that experience, and like was just mentioned, we're a bit of a dinosaur, and we're very conservative by nature, especially when it comes to the idea that our buildings will fall down. But we have years of data to back up what we want to do, and can kind of rely on our European or other counterparts around the world and kind of take their methodologies. It's expensive, but it makes it a little bit easier to adopt those kinds of things.
So how can we, as the data center industry, help accelerate this process?
Again, opening up your specs. Find companies like Holcim, and I'm not saying just Holcim, this is my personal pitch, but the more we've engaged earlier, a lot of these materials are regional. For example, a lot of what we use is slag cement, which is a byproduct of steel manufacturing. We grind that and we can turn that into a really high quality material. But if you don't allow us to use it on your project, we've never been encouraged to do so. 5-6 years ago as a cement manufacturer, I'm not trying to sound arrogant, I never would have cared to talk to you guys at all. Anybody, building anything, I want to talk to the contractors and stay away from it because that reduces my risk, just quite frankly, right? But over the last few years, we've really started to engage with owners, and that's helped us expand those specs and write them in a way that allows us to get more innovative on our side of the supply chain, which has paid huge dividends, not just for us, but for the industry as a whole. And I think that's why, in the case of 1L in the last couple of years, you saw every major cement manufacturer follow our lead and just switch over, because we all just kind of, not that we talk to each other, because we're not allowed to through anti-competitive laws, but I think once the big dog did it, and there was enough noise going around from folks like a lot of you in this room, or the companies that you represent, it kind of gave us that permission to say, you know what, this is what we're doing, and we don't care who's upset about it. It's been done in other parts of the world for decades. It's the easiest step we can take, and so everybody went to it, right? So that's what you can do, is engage early, learn what we're doing, look at all the alternatives out there, and if there's, in the startup space, there's all kinds of really interesting stuff going on in that area. They need little pilot projects. They need to test their new materials in low risk applications. There's so many ways that you can get involved with your supply chain that it really can pay dividends for your company, long term. So I appreciate that, though.
Last question. So very short for Karl first, and then a second question for you, Karl. What is the reason you think we don't see so many wooden buildings generally? The main reason. And for you, a question is about now concrete. I don't know where, maybe it's fake news, maybe I read it on Twitter. There are some concrete, maybe with some coatings that are actively capturing carbon. Are you working on that kind of innovations as well, on some different ingredients that are actively capturing carbon from the ambient air? Thanks.
So first question for me, so we see a lot of wooden buildings, especially, for example, the US has a massive history, and I think most wooden houses, or most housing is wooden. And it depends a little bit on your cultural background, and really this is like the amount of mass timber and mass timber engineering really is relatively new, relatively young, and I think that's what the first one is always the hardest, and pushing towards that and seeing more and more examples popping up, like literally having the race for the highest building on both sides of the Atlantic. I think this will rapidly change. The main enabler in countries where already wooden data centers exist is tax hard on embedded carbon, right? If this, building all of a sudden is 30% more expensive, you choose this cheaper option. We all only are cost animals, right? And so where it's happening because of taxation.
And just to get clarification, do you mean carbon capture on the cement plant or carbon capture where the concrete reabsorbs CO2 out of the atmosphere? Is that what you mean?
Yeah, or in the building. In the building.
In the building, yeah. So we've known for a long time that concrete does recarbonize. It's really hard to measure. Again, there's some startups in that area that are working on some pretty interesting new technologies. The way we, as what we call ourselves the incumbent in the industry, right? We're the dominator of, I mean, any cement manufacturer is the incumbent. The startups are obviously new entrants. We see our role in that kind of activity. We have a group called our Maker Ventures, and that's a group that incubates new startups in our space. There's a lot of metrics we look at for that because there's end product development. There's also development that can help our production processes like carbon capture technologies and things like that. But that's how we would work with various companies that are developing what you're talking about there. And the only thing I've seen.
I think we have to wrap it up, Zach. I already get very angry eyes from my friends. So thanks so much. Thanks.
Thank you.